Scalar is only magnitude. You can add 1 plus 2, it is 3. 3 plus 1, it is 4. You can add scalars easily. So you can add the magnitudes easily. But how will you add vector? Two adjacent side is connecting where? At point O. From here we'll draw the diagonal. So this is a resultant vector. When we have three vectors A, B and C, taking a parallelogram, again we can obtain a associative law. Hello everyone, welcome back to session 2 on chapter 4, motion in a plane. I am Nishmananjama, faculty of physics in Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. So in session 1, we studied what is motion in a plane, what is position vector, what is displacement vector, what is equality of vector, how do we represent a vector, what is scalar and what is vector. So in this session 2 of chapter 4, motion in a plane, we shall discuss the multiplication of vector by real numbers. So what is real numbers? 1, 2, 3, 4, etc. So multiplication of vector, addition of vector, subtraction of vector, all these will detail be studied in this chapter. So in this session, we shall study what is the multiplication of vector, how do we multiply vectors, and we shall study the vector addition, the three types of vectors, vector addition, triangle law, parallelogram law, polygon law, and also we shall study the properties of vector. So let's begin the session. Multiplication of vector using real numbers. So what is this multiplication of vector? Multiplying a vector A with positive number lambda gives a vector lambda A whose magnitude is changed by the factor lambda, but the direction remains same as that of A. So multiplication, you're multiplying vector A with some positive number lambda. So it will give you a new vector, that is lambda A, whose magnitude is changed by this factor lambda, but the direction will remain same as that of A. For example, it is given as mod lambda A vector is equal to lambda times the A vector. For example, if vector A is multiplied, multiplication by a real number 3, then the resultant vector, the new vector which you get, then the resultant vector will be 3 times the A vector. For example, you have a vector A, multiplied by a real positive number 3. So that will give you a new vector, that is 3 times the vector A. That will give you 3 times the vector A. For example, I have force. Force is your vector quantity which gives both direction and magnitude. So force is a vector quantity. So I applied 5 Newton of force. That means 5 Newton of force. So that will give me 5 times the force. The force is doubled. It is 5 times the force. I applied 5 Newton of force. So it is 5 times the force. It is double. The force is doubled. So the magnitude, and it has both direction. So the magnitude is changed. It is, I multiplied a real number, a positive number 5 here. So the magnitude, new vector when I get, the magnitude is changed, but the direction is along same as that of force. The direction remains same as that of the direction of force. Similarly, example 2. If you multiply a vector A vector A with -3 with a negative number. If you multiply a vector with a negative number, then you will get -3 times the vector A, -3 times the vector A. So here you can see the magnitude is changed by the factor -3. Magnitude of vector A is changed by the factor -3. The direction is not same as that of A because the direction is along the negative axis. The direction is along the negative axis. So vector A is multiplied by -3, negative number. So you have got a new resultant vector, -3 mod of A. So it is the vector is changed by magnitude -3 and the direction is opposite to that of A because it is minus, opposite to that of A. So multiplying a vector A with a positive number lambda or a positive number 3 gives a new resultant vector lambda A. So here it is 3A whose magnitude is changed by factor 3. I multiply with magnitude 3. So a new vector is changed by the factor lambda. Here it is changed by factor 3. But the direction is same as that of A here. Same as that of A. Magnitude is changed. I multiplied a factor lambda. I multiplied a factor 3. Magnitude is changed, but the direction of vector remains same. It is +3, so it remains same as that of A. But it is reverse in case of when you multiply a negative. When you multiply a negative number. So this is true if lambda is greater than 0 and if lambda is positive number. So this magnitude is changed by factor lambda, but the direction is same as that of A. This multiplication, it is true if lambda is a positive number, lambda is greater than 0. If it is negative, then the direction will become opposite, not same as that of A. So this is about the multiplication of vector. Next you have vector addition. What is this vector addition? So A, you have two vectors A plus B is equal to what? How do you add two vectors? Because vector gives both magnitude and direction. So when you talk about addition of scalars, scalar is only magnitude. You can add 1 plus 2, it is 3. 3 plus 1, it is 4. You can add scalars easily. So you can add the magnitudes easily. But how will you add vector? Vector depends on both magnitude as well as direction. I can easily add off the magnitude. But how will you add the direction when you talk about vector addition? For example, addition of scalar, you have two rods. Rod 2 and rod 1. I have two rods. The length of the rod 1, it is 2 meter and mass, it is 4 kg. For example, the rod 2, the length L2 is 3 meter, mass M2 is 2 kg. So, I want to know what is the length of the rod, overall length of the rod L1, rod 1 and rod 2. So, I will add L1 plus L2, that is equal to 5 meter. So, addition of scalar is easier. Addition of scalar just follows ordinary algebra. So, you can add length L1, L2, mass M1 and M2 to know the overall mass of the rod. Can you add L1 plus M2? Length of rod 1 and mass of rod 2? No, this is not possible because you can add or subtract if the units are same, if they are representing same physical quantity. So, your length is in meter and your mass is in kg. So, you cannot add two different units or two different physical quantities. So, this is wrong. You can add length to length or mass to mass. So, you can get the length or mass of the rod. So, addition of scalar follows the rules of ordinary algebra. So addition of scalar, the magnitude, that is nothing but numerical values, can be added off easily. So when you talk about vector addition, vector gives both magnitude and direction. Magnitude is what? A numerical value. If I can add the magnitude, then how will I add the direction? So that we will be studying in the vector addition in today's session. So vector addition, we have three important laws. It is very important. Triangle law of addition, vector addition, parallelogram law of vector addition. So Polygon law of vector addition. So you have triangle law. So you have parallelogram law of vector addition, and also you have a polygon law of vector addition. It has five sides. So we'll first start with triangle law. Let us try to understand what does triangle law of vector addition tells. How do we perform the triangle law of vector addition? So addition of vectors, graphical method. This is also called graphical method or triangle law of vector addition. The vector addition is also called head to tail method. Also called head to tail method. So don't get confused. So first is triangle law of vector addition. Let us try to understand what is this triangle law. It states that if two vectors are represented both in magnitude and direction by two sides of the triangle taken in order, then the resultant vector is represented by the third side of the triangle taken in the opposite direction. So what does this mean? So this is your triangle. This is your triangle. You have 1, 2 and 3 sides. You have 1, 2 and 3 sides. So what I'll do? I will draw a line in this direction. Name it as PQ. Name it as PQ. I'll draw a line in this direction, PQ. And this side PQ, the first side of the triangle PQ, is represented by a vector A. Similarly, I will draw another line from the head of the arrow, that is QS. So the second side of the triangle, that is QS, is represented by a vector B. So the two sides are in the same direction. It is in the same direction. The third side PS is represented in opposite side. That means instead of writing an arrow down, I'll write the arrow towards up. So two arrows are meeting at the head. Two arrows of the two lines, two arrows are connected at the head point. So this PS gives me the resultant vector R. So the side PQ, A vector represents the side PQ, B vector represents the side QS, and the third side, which is opposite to A and B, represents the resultant vector R. So PQ is equal to A vector, QS is equal to B vector, and PS is equal to R vector. Is equal to R vector. So your R vector will be sum of two sides. Your R vector will be sum of two sides, that is A vector plus B vector. So this is the triangle law of vector addition. So how is this? We have explained in the previous session that if you have an arrow, this is your tail, this is your head. So tail. So I'll draw a line PQ. To the head of the line PQ, the tail of the line QS is connected, and to the head of the arrow SQ, the head of the arrow PR is connected. So the two tails of line PQ, of arrow PQ and PS are connected at this point. For example, if you have a triangle in this direction and in this direction, and if you draw the line again in opposite direction, this is wrong. Why? The triangle law says that the resultant vector, that this is the resultant vector, is represented by third side. So this is the third side and represented by third side of the triangle taken in opposite order. So it should be taken in opposite order. If this line is represented towards this side and this line is represented towards up, instead of representing it in the same way towards down, we should represent it in the opposite direction. So that is your triangle law of vector addition. Suppose you have vector A and you have vector B. I have to join these two lines to create a triangle law of vector addition. How will I join? I have vector A. Carefully I'll bring back this arrow and place it to the head of the arrow such that this represents vector B. We should bring back this line B in the same way that its direction and magnitude should not change. Its direction and magnitude should not change, and we will fix it to the head of the arrow like this. So this is the triangle law of vector addition. So it states that if two vectors represent both, if two vectors are represented both in magnitude and direction, both in magnitude and direction by any two sides of the triangle. So you have a triangle, you have two vectors A and B represented both in magnitude and direction. You can see its direction by two sides of the triangle in the same order. So you have arrow in this side, you have arrow in this side. They are in the same order. Then the resultant vector, that is the opposite side, that is the third side. The resultant vector is given by R. It is represented by the third side of the triangle taken in the opposite order. So instead of taking the arrow in this order, the rule says that, the law says that it should be taken in the opposite order such that the tail of the line PQ should be connected with the tail of the line PS. So the arrow of the line PS should be connected with arrow of the line QS, and the arrow of the line PQ should be connected with the tail of the line QS. So this is the triangle law. So resultant vector is sum of the two vectors of two sides of the triangle. So this is the triangle law of vector addition. Next you have parallelogram law of vector addition. So what does parallelogram means? Parallelogram law of vector addition. Parallelogram should have two parallel sides in it. So parallelogram law of vector addition states that if two vectors are represented both in magnitude and direction, the vectors are represented both in magnitude and direction by the two adjacent side of a parallelogram, then the resultant vector is represented by the diagonal drawn from the same point of application. So let us try to understand this. So this is the parallelogram. This is how the parallelogram looks. Two adjacent sides. I'll draw two sides, OP and OQ. So this is the two sides of the parallelogram. So you can see the tail of the line OQ is intersecting with the tail of the line OP. So it is in this direction. The direction is given along like this. So the tail of the line OQ is intersecting with the tail of the line OP. So this is the intersecting point. That is why we call it as a two adjacent sides of the parallelogram. Now we shall complete this parallelogram because we know parallelogram has two parallel sides. OP is parallel to OS. So it is in this direction. Don't have direction. So we shall complete this parallelogram. We know parallelogram has two parallel sides. So this is S. So OP is parallel to QS. OQ is parallel to PS. So it is a parallelogram now. So the adjacent side is making an angle theta. Line OQ is making angle theta with line OP. So the resultant vector is represented by diagonal. In case of parallel vector, it is the diagonal which passes from the center point. That is the two adjacent sides are interacting at point O. From the center, we draw a diagonal. So this diagonal gives you my resultant vector. In case of triangle law, the opposite, the third side represents the resultant vector. In case of parallelogram law, it is the diagonal of the parallelogram which is giving me my resultant vector. So if OP side is represented by vector A, then OQ side is represented by vector B, and OS is the diagonal that gives the resultant vector R. Since the sides of the parallelogram are parallel, B, if OQ is B is represented by vector B, then PS is parallel to OQ. It is also represented by vector B, and OP is parallel to QS. So A vector represents sides OP. So QS is also represented by vector A. So this is your parallelogram. So R, the direction R is making an angle alpha with direction of A. Two adjacent sides of parallelogram are making angle theta. So direction of R is making angle alpha with direction of A. So how will you study parallelogram law now? So side OP, A represents side OP of the parallelogram. You can see OQ. B vector represents the side OQ of the parallelogram. So the resultant vector R, that is given by the diagonal of the parallelogram, that is nothing but OP plus OQ. What is R here? OS. OS is equal to OP plus OQ. So R is equal to vector A plus vector B. So we can add two sides of the parallelogram, or to add two sides of the triangle, we use triangle or parallelogram law. So if you want to add the vector which has more than two or three sides or two or three vectors. So to add two vectors, we can use parallelogram or triangle law. In case if you want to add two or three or more vectors, we use Polygon law of vector addition. We'll come to that. So what is parallelogram law of vector addition? It states that if two vectors are represented, that is vector A and vector B. Vector A and vector B are represented both in magnitude and direction. By two adjacent side of the parallelogram. So this is the two adjacent side of the parallelogram, where the tail of the line OP is connected to the tail of the arrow OQ. So this is your adjacent side. From the adjacent side only we'll draw the diagonal of the parallelogram. So here you can see parallelogram. Then the resultant vector is represented by the diagonal drawn from the same point of application. From the two adjacent side is connecting where? At point O. From here we'll draw the diagonal. So this is a resultant vector. Resultant vector is equal to sum of two adjacent sides A and B. So R is equal to A plus B. So this is your parallelogram law of vector addition. So if you have three or more vectors, we use Polygon law of polygon of vector addition. Polygon which has 5 sides. So law of polygon of vector addition. So you can see you have vector A, B, C, D and a resultant vector R. So you have more than two vectors. In parallelogram and triangle law, you used to study only two vectors, A, B, sum of A, B. So here there are more 3-4 vectors, A, B, C, D. To study the addition of two or more vectors, we use Polygon law of vector addition. You can see this is the polygon, representation of polygon. So what does the law states? It states that if a number of vectors are represented, if the number of vectors 1, 2, 3, 4, number of vectors are represented both in magnitude and direction by sides of the polygon, taken in same order. You can see it is taken in same order. Then the resultant vector is represented in magnitude and direction by the closing side. You can see it is opposite. All the arrows are following same direction, but OT, this is the closing side of the polygon, taken in opposite order. You can see it is taken in opposite order. Instead of this arrow, they have placed it in the opposite direction. So this gives your resultant vector. Suppose you have vector, you have a line, arrow OP, which is represented by a vector A, and again you have an arrow from head of the OP. I am drawing a line OPQ, which is in the same order. From the head, I have drawn a line PQ. Again, from the head of the line PQ, I am drawing a line QS. Again, from the head of the line QS, I am drawing a line T. So you can see they are in the same order. All the sides of the polygon are in the same order. From the head of the line OP, I am drawing a line PQ. Again, from the head of the line PQ, I am drawing a line QS. Again, from the head of the line S, I am drawing a line ST. So they are in the same order. So A represents the vector A represents side OP, vector B represents side PQ, and vector C represents the side QS, and vector D represents the side ST. So we have 4 vector, 4 sides. So the closing side of the polygon, let us say, this is the closing side of the polygon OT. OT is the closing side of the polygon, which is not in the same order. It is in the opposite order. So from the head of the line ST, I am drawing the head of the line OT. So you can see the tail of the line OT is connected to tail of the line OP. So this side of the polygon gives me my resultant vector. It is in opposite direction. Instead of from the head of line ST, the tail should be connected to the line OP. If that was the case, then it is wrong. So it should be in opposite direction. So from the head of the line ST, I am connecting the head of the line OT, so that the tail of line OT and OP are intersecting. So this is the polygon. OP is equal to A. OP side of polygon represents A vector. PQ sides represent B vector. SQ side represents C vector. And ST side of the polygon represents D vector. So resultant vector OT is equal to sum of all the sides of the polygon which are in same order. OP plus PQ plus SQ plus ST gives the resultant vector OT. So R is equal to vector A plus vector B plus C plus D. So this is your polygon law of vector addition. You can add 3 or more vectors in polygon law of vector addition, where the closing side of the polygon gives you your resultant vector, which is opposite to the order of other sides of the polygon. So it states that if the number of vectors are represented both in magnitude and direction by the sides of the polygon, taken in same order, then the resultant vector represented in magnitude and direction by the closing side of the polygon, taken in opposite direction, taken in opposite direction. So this is your law of polygon of vector addition. So next you have properties of vector addition. Next you have properties of vector addition. What is the first property? Vector addition is always commutative. You will learn this in your PU mathematics, what is commutative and what is associative. Vector addition is always commutative. You will have two vectors when you talk about commutative, A vector and B vector. A vector plus B vector is equal to B vector plus A vector. For example, consider a parallelogram which has two adjacent sides, say OP, say it is A, this is B, and I will complete this parallelogram by dropping a perpendicular to B. We know the sides of the parallelogram are parallel to each other. So this is AB, so this is my C and this is my D. This is the parallelogram, and we know from the two adjacent sides of the parallelogram, so this is the direction. So you can see two tails of the two arrow intersecting at point A. So this is the adjacent side. From the adjacent side, we will usually draw a diagonal. So this will give you the resultant vector. So this is a parallelogram. So can you see there are two triangles here? Consider a triangle and consider a triangle. We have two triangles ADC. So this is your second triangle. This is your first triangle. From triangle ABC, from triangle ABC, so this is given by vector A and this is given by vector B. Since they are parallel, AB is parallel to DC, this is also A. AD is parallel to BC, this is also given by vector B. That is the parallelogram. So from triangle ABC, the yellow line which you can see. So what is AB? AB is represented by vector A and BC is represented by vector B. So what is A plus B? So what is AB plus BC? Will give you the diagonal AC. So it will be A plus B is equal to AC. Similarly, from the second triangle, which is the second triangle, ADC, the green line, ADC, what are the two sides? AD is represented by vector B and DC is represented by vector A. So, AD plus DC gives you diagonal AC. So, we know right angle triangle, hypotenuse by opposite by adjacent. So, we will get AD is B plus DC is what? A, gives you AC. So, AC here, AC here. So, equating 1 and 2, I will get A plus B is equal to B plus A. This is your commutative law. So, vector addition is always commutative. A plus B is equal to B plus A. You consider a parallelogram. You can see parallelogram has two parallel sides. AB is parallel to DC. AD is parallel to BC. So, a resultant is given by a diagonal passing from two adjacent sides in case of parallelogram. We studied that in the parallelogram law of vector addition. So, you have two triangles here. The yellow represents triangle ABC, the green represents triangle ADC. So, from triangle, this is a right angle triangle ABC. So, AB is represented by vector A. Again, BC is represented by vector B. So, A plus B is equal to the hypotenuse, the diagonal AC. So, A plus B is equal to AC. I got one equation. From triangle, second triangle ADC, from this triangle, right angle triangle, AD is B, DC is A, because vector A, because they are parallel sides. So AD plus DC is equal to AC. Again, I got second equation. On equating equation 1 and 2, I'll get the commutative law, that is vector addition is always commutative. Similarly, you have associative. What is associative? In case of associative, we'll have three vectors A, B and C. When we have three vectors A, B and C, taking a parallelogram, again we can obtain a associative law. You can do it for yourself. How? By taking a parallelogram A, B, C, D and a diagonal. How will you arrive at associative law which has three vectors A, B and C? Similar to commutative, but here you have three vectors instead of two. So vector addition is always associative, vector addition is always commutative. That is the properties of vector addition. Associative means A plus B plus C, again A plus B plus C. You can see the change of brackets for the vector. So this is associative. Vector addition is associative. Next you have when the negative of vector is added to a given vector. When the negative of vector is added to the given vector, then the resultant vector is null vector or a zero vector. Null vector or a zero vector. A negative, when the negative of vector, for example, you have 2. When you add a negative of vector, when you add -2, plus minus is minus, 2 minus 2 is 0 again. Similarly, when a negative vector, we are talking about vector which has direction also. So you have a vector A, consider a vector A. It is added, a negative vector will be added to the given vector. So you have vector A plus a negative vector is added to vector A. Added, a -2 is added to +2. Negative vector A is added to vector A. So that will give you a null vector or a zero vector, which means it has zero magnitude and direction is arbitrary. Thus, minimum of two vectors, say A and B, are required to get the resultant as a zero vector. So minimum of two vectors is required to get a resultant as a zero vector. A zero vector also results when we multiply a vector with a scalar 0. With a scalar 0. Scalar gives what? Only magnitude, no direction. So a zero vector, we can get a zero vector. When we multiply a vector, say A or B, I have a vector B. I'll multiply a vector with a scalar 0. 1, 2, 3, 4, 5, 0. All these are scalars, magnitudes, a numerical value. When I multiply a given vector B with a scalar 0, I can get a zero vector as the resultant. So these are the properties of vector addition. What are the properties? Vector addition is commutative. Vector addition is associative. When a negative vector is added to a given vector A, the resultant will be null vector. Thus, we need at least two vectors to get the resultant as a zero or a null vector. A zero vector is added. We can get a result as a zero vector when the given vector is multiplied by a scalar. When the given vector is multiplied by a scalar, that is 0, we get a resultant vector as a zero vector. So, in today's session, we studied what is multiplication of vector by real numbers. So, we studied multiplication using an example of a positive number as well as negative number. The multiplication of vector holds true only for positive number. The multiplication of vector addition holds true only for the positive number lambda, and lambda is greater than 0. If negative, we have seen that the direction of vector will not be along A, it will be opposite to the direction of A. Next, we studied vector addition. To add scalars, we can add the magnitude in ordinary algebra, but when it comes to vector addition, we can add the magnitude by chance, but how will we add the direction? We studied triangle law, parallelogram law, polygon law of vector addition. In triangle law, we saw resultant R is equal to 2 sides A plus B. And in parallelogram law, we consider a parallelogram which has 2 parallel sides. Resultant R is equal to addition of 2 adjacent side A plus B. So to add 3 or more vectors, we considered polygon law, where we saw the addition of 3 to 4 vectors. So resultant vector is given by the closing side of the polygon, whereas in parallelogram law, the diagonal gives the resultant vector, and in triangle, the third side, which is opposite to side 1 and 2, will give you the resultant vector. Then we studied the properties of vector addition, that it is commutative, it is associative, and the negative vector is added to a given vector. The resultant vector is null vector, and we can get null vector by multiplying a given vector with a scalar 0. So these are the properties. So that's all for today's session. Next, I'll be coming up with more interesting session in motion in a plane, where we'll study the projectile motion and the circular motion. Until then, take care. Have a good day. Thank you.